But what we're going to be more focused on, exclusively focused on today, is what we call bottom-up mechanisms. And that involves competition between ecologically similar species and how that leads to what we call niche partitioning, so differentiation in resource use, okay? Now, there's a couple of different ways you can think about niche partitioning. You can think about it in space. So here are 6 different antelope species that are coexisting in a sort of grassy open woodland savanna with a little swamp in it. And they're occupying particular niches in this habitat. So the reedbuck in the reeds over there, the nyala in the deep woods. And this is a common form of niche partitioning. It's associated with the ecologist Joseph Grinnell. And another classic example you guys might have come across is anolis lizards, which partition the vertical tree canopy. So ungulates, or large hoofed mammals, can do that too. Dietary niche partitioning is another key mechanism that we need to consider. And the way this has been thought about in the case of these big, large mammals here is largely in terms of something called the grazer-browser spectrum. So over here on the left we have zebra. That's a grazer. Means it eats predominantly grass. And over there on the right we have a dik-dik, and it eats almost exclusively non-grass or browse. And for those of you guys who don't know what a dik-dik looks like, it's a 5-kilogram antelope. We happen to have a replica skull here. So that's dik-dik, and it's got, if we were to look at the cranial morphology and the teeth of that replica, we'd be able to see adaptations to a browsing lifestyle, or rather we'd be able to see the absence of adaptations to a grazing lifestyle. And then in the middle we have what we call mixed feeders. So this impala might eat a 50-50 mix of both grasses and browse. Okay? So that's the grazer-browser spectrum. Another form of dietary niche partitioning is that animals can separate out by height. All right? So this one should make intuitive sense. If you've got 3 large browsers, again, browsers being the ones that eat trees and don't eat grasses. So here we have giraffe, kudu, and steinbuck, and feeding along a height axis on a tree. And the proportion of time that they spend feeding is there on the x-axis, and you see the giraffe spends most of its time feeding on the tall parts of the tree, the kudu at the intermediate parts, and the steinbuck at the lowest parts. Believe it or not, something similar is true for how grazers partition their grass. So if we have, again, our one grass species, this is our Panicum maximum buffalo grass. This is the examples from the Serengeti, where they have a long dry season. And when the rains come, the grass grows tall. And the first herbivores to move in to start foraging on that tall grass are zebra, which they're non-ruminant and large body-sized animals, which means they have to eat a lot of food and they don't digest it very thoroughly. So that's kind of their strategy. So they move in and they eat this grass, which is relatively low quality, has a lot of stems. They're followed by wildebeests, who prefer grass of a slightly intermediate height and slightly higher quality, because as the grass gets shorter, then we're getting to the more nutritious parts of it. And lastly, the smallest and most selective herbivore species, Thompson's gazelle, is feeding at the smallest, the shortest grass that you find sort of 6 months after the rain, after the other herbivores have passed through. And this is a phenomenon known as grazing succession. And it also relates to a concept known as facilitation, because zebra are thought to be sort of preparing, if you will, the range or the pasture for wildebeest, and wildebeest further prepare it for Thompson's gazelle. So they're actually a positive as opposed to a competitive interaction among these species in this situation.